Hi, okay, we're at session 14. I've got a big variety of questions there for you to have a go at in the recap. So hit pause, press play when you're ready. And there are your answers. Again, hit pause and mark through. Okay, so hopefully that has gone well, and we're just going to crack on with the next piece of learning. So we're going to be looking at probability. Probability lies on a number line. It has a scale that starts at 0 and finishes at what? And when I ask that question in class, a lot of people say to me 100%. Percentages are not really used for probability. Certainly not when we get into the working out stages. You might get the odd question that says the probability that it will, I don't know, rain is 15%. But that's pretty much the only place you're going to see it. And certainly when we're problem solving, we never see it. So it's really important that we don't link that 100% to our kind of scale, our line that represents probability. The number is 1. Okay, so probability goes from 0 to 1. And everything in between 0 to 1 is either a fraction or a decimal. And that is what we tend to work in when it comes to probability. I've written fraction first because that is even more common. Now, quite often people don't like the idea of fractions. They think that that means it's going to be harder, but it's really, really not. Probability with fractions is easier, in fact, than probability with decimals. Okay, so let's crack on. One last thing, actually, before I rub out this scale. The 0 represents absolutely impossible, just absolutely not happening. So Christmas Day, moving from the 25th of December to the 3rd of April, it's never going to happen. Okay, it's impossible. It's got a 0 chance. And then 1 is the opposite of that. It's an absolute certainty. So me waking up tomorrow as female, that is going to happen. That's an absolute certainty. All right. If I get an answer when I'm working in probability that's greater than 1, I've gone wrong. It's really as simple as that. An answer in probability lies between 0 and 1. And those are the minimum and maximums. Okay, so that's really, really important. Okay, let's rub this out and think about that probability and it adding to 1. Now, what I mean by it adding to 1 is if you have an event, let's say I gave rain as an example a moment ago. Let's say I'm telling you that the probability of it raining is 1/4. Then the probability of it not raining has to be a fraction that adds to 1. The reason for this, there's my scale. I'm going to highlight that there. That's my rain, represented by 1/4. 0 is it absolutely not happening. Well, it's either going to rain or it's not going to rain. That's a certainty. So the rain and the not going to rain must add together to make that 1. And hopefully this visual kind of makes sense. So the missing fraction is going to be 3/4. And 1/4 plus 3/4 is equal to 1. So if I give you a question and I want the opposite of that happening, then the answer, the value, must add to 1, all right? Because 1 is our probability maximum, all right? Let's do another question similar to that. So let's say the probability that I eat some sweets today is 3/10. Then the probability of me not eating sweets, so the opposite, has to be an answer that would add to the 3/10 to make 1. And the answer to that is 7/10. Okay, if you're wondering how this is happening, the numerators have to add to the denominator. 3 plus 7 is 10. The exact same thing happened here. 1 plus 3 is 4. Okay, now I could make up the story about anything. The problem I stop at a traffic light is 2/7. So the probability I go or I not stop has to be 5/7. And hopefully we are feeling comfortable with this area of probability. Okay, probability I eat lunch today is 0.9. So I've gone into decimals. This is a very common area where decimals can crop up actually. So the probability that I miss lunch, the opposite, remember this has to add to 1. It's going to be 0.1. Some people think in money when they're working in decimals because they're familiar with money and they find that easier. So if you need something like that to help you, then make sure you do it. So I can give these types of questions in fractions. I can give them in decimals. Now, this is really important. The answer, like 0.1 for that question, is correct. But these are 2-mark questions. And if all I do is write down the answer, 0.1, then I'm risking a mark. I'm only going to get 1 out of the possible 2. So where is the method? I know what's happening in my head, but what is it that I've got to write down? And again, it comes back to this 1. Yeah, the maths we did was 0.9 plus something. That was what we were trying to work out, is equal to 1. So the maths that I would do is 1 take 0.9. That there is going to give me another mark. So going back up to these questions here, where I just wrote the answers, what I need to do is show, I know it's supposed to add to 1. 1 take away what you've given me, and that is enough to get that mark. I know it adds to 1, take away what you've given me, and again, my method mark is there. So when you're working with the opposite of each other, they always add to 1, and we must show the 1 minus if we're going to get full marks in our GCSE. Okay, so next type of question we see are where you've been given items, marbles in a bag, that type of thing's really, really common. So this should feel quite familiar, hopefully. And then you're just asked questions about it. So I could say to you, what's the probability that I pick a red marble? So you haven't been given a starting point, you haven't been given a fraction, you haven't been given a decimal. So you've got to decide how you're going to work. And this is where the fractions just come into their own and they make life really, really easy. How many red balls can you actually see, or marbles? I'm changing what they are now. How many red marbles can you see? 1 out of how many altogether? And we've got 1, 2, 3, 4, 5, 6. And that's it. So actually just counting and knowing what to put on the top and what to put on the bottom is all you have to do. So the top is what the question's referring to. So the item, the category, etc., etc. And the bottom is always the total of whatever is there. Okay, so that is generally how we pull the fraction together. Let's do another one. We've got the probability of picking a black. What would that be? And hopefully you're shouting the answer out at the screen. So the answer is 3/6. And that's it. Now, you may be wondering if we should be cancelling. And the answer to that is no, there is no expectation that probability questions are cancelled. So we don't have to do that. We can literally just get that fraction pulled together and we can leave it at that. Okay, what's the probability of not picking blue? Of not picking blue? Have a little think about that, and then feel free to just in your head or shout out, have an answer. So really what I'm being told to do here is ignore the blues. I can pick anything as long as it's not blue. So I've got red and black that I can pick. So I've got 4 that I can pick out of a total of 6 that are there. Okay. So we can have combined questions. What's the probability of picking red or blue? And again, that's just telling you to count the reds and the blues. I've got 3 of those in total out of 6. So pulling that fraction together is really, really simple. If I tried to write that as a decimal, I wouldn't even know where to start. All right, 6ths as decimals are not an easy fraction to just know as a decimal. So we're not going there. Okay, let's have a look at a different type of question. So we've got the word percentages. And I'm going to ask you to write down the probability. Let's say the word percentage has been cut up, the letters have been put into a bag, and I'm just going to randomly pick a letter. What is the probability I pick an E? Take your time. Okay, so I've got 1, 2, 3 E's. And then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 11 letters in total. So that's my probability of getting an E. Okay. What's my probability of getting a D? Okay. There isn't a D. So there is a 0 chance. It's impossible. I can't pick a D. It's impossible, and impossible is 0. Now, a lot of students will do that. Okay. Really important. 0 is 0. Okay. We're not going to be setting it up as a fraction. So we've got to know to just write 0. Okay. What about this question? Probability probability of picking a letter. How am I going to word this? Picking a letter that is one of the first 5 in the alphabet. I hope that makes sense. There we go. So what's the probability that I go in and I pick a letter, and the letter that I get is one of the first 5 letters of the alphabet? That's what I'm trying to write there. Okay, so A is there, B isn't, C, A, B, C, D, and then E. 1, 2, 3. I've got 1, 2, 3, 4, 5. So the probability is 5 out of 11. And that is pretty much it in a nutshell. Okay. So obviously you're going to have some practice questions at the end. We're going to have a quick look at listing, and then we're going to combine the 2 together. Okay. So listing outcomes. We are often given some information, and then we're asked to list all the possible combinations. Menus are really common, so I thought we'd start there. So I've got a menu, and the story will go something like, you know, a customer arrives and he's going to have a 3-course meal. write down all the possible combinations that he could have from this menu, okay? If you jump about with the way that you do this, then you are risking missing certain combinations. So this type of thing requires quite a sort of systematic, careful approach. And if you do that, then they generally become easier to deal with. So let me show you what I mean. If I'm going to do this systematically, then I'm going to say, right, obviously I'm going to start with soup. I don't have any other option. I'm then going to have curry, and I'll have that with the crumble, and I'll put a little R or something there just to show that that's my crumble. I'm not writing it all out in full. I don't need to, and the examiner doesn't expect you to either. As long as it's clear what your combinations are, then they're going to be perfectly happy with what you're doing here, okay? Then I'm going to start with my soup and my curry again. I'm not going to change that, and I'm going to go for the other option of pud, which is ice cream. So that's my soup, curry, and the two possible puds that go with it. I'll then do, obviously, soup because I've got no choice. With the roast, I'll do that with my crumble, and then soup, roast, and ice cream. And that is actually all the combinations that are available to the customer if that is all that's on the menu. Okay, so listing requires you to be very ordered, if you like, in the way that you pull all the combinations together. And that is it. They are generally 2-mark questions, 2 marks for getting them all. But this is how you can lose a mark, obviously by not listing them all. But if you start swapping them around, if you say you've got soup with curry and ice cream, and then you say, and another combination would be curry soup with ice cream, or ice cream with soup and curry, and you just start rearranging them into different positions, they're not actually different combinations. You're still having soup, you're still having the curry, and you're still having the ice cream. So those additional combinations don't count. And if you add them in, you will be penalized and they will drop you off a mark. So really important that we're aware of that as well. So let's look at a different question. So Jamie tosses a coin and throws a dice. So this is a fair 6-sided dice. And you're being asked to write down all the possible combinations. So I think it would be really good if you hit pause and actually took a couple of minutes to write down all those combinations. And remember, be ordered in your approach. Okay, so I'm going to say I've got heads on the coin and the number 1 on my dice. I'm then going to say I could have heads with 2, I could have heads with 3, heads with 4, heads with 5, heads with 6. And then I'm going to have tails with 1, tails with 2, and obviously I'm going to just keep working my way along till I've listed them all. That was my way of listing it. You might have done H1, T1, H2, T2, etc., etc. There's no right or wrong way. As long as you are doing it in a way that means you don't miss any off, you're going to get all your marks, aren't you? Because you're going to have listed all the possible outcomes. Now, they can also link probability as a second part to this style of question. So let's do that and have a little go. So what's the probability that I get a head and the number 6? Okay. Head and the number 6 is here. It doesn't come up anywhere else in the list. So I actually have 1 out of a total of 12. Okay. What's the probability I get a tail and an even number? Okay, so I've got even. So I've got 3 even numbers with my tails. So it's going to be 3 out of 12. Okay, So nothing's changed with the way that we approach the probability. We've just created the combination so that we can find the totals ourselves. All right. Okay, let's do one more. Clean that off. Okay, so there are 3 biscuits on a plate, a rich tea, a custard cream, and a hobnob. I want you to write down all the different ways they could be eaten. Okay, so again, hit that pause just to give yourself a chance to get those written down, and then we will look at those answers. So again, it's just being systematic. Your starting point might be different to mine. So don't suddenly think you're wrong. I'm going to start with the rich tea because it's the first in the list. And then I'm going to go custard cream and hobnob again, really, because it was the list that it was given to me in. But then I'm going to stick with the rich tea. I could eat the custard cream next and then the hobnob, or I could eat the hobnob and then the custard cream. But they are all the combinations that I have available to me, starting with a rich tea. So now I'm going to start with a custard cream. I could go custard cream, eat the rich tea and then the hobnob, or I could go custard cream, eat the hobnob, and then the rich tea, getting tongue-tied. Or I could start with my hobnob, eat the rich tea and then the custard cream, or again, the other way around. So those are all my combinations. I've got 6 of them in total. I would have needed to have got at least 4 to have 1 mark. So if I got 3 and no more than that, I wouldn't get any marks at all. So I would get at least 4. So you've got to get over half in order to get your first mark. You get your second mark if you get them all, and then you lose a mark if you write some combinations that are already there, but in a different order. Okay. And let's do a probability against it. What's the probability? I eat hobnob second. So as I'm munching through my biscuits, what's the probability that the hobnob gets eaten second? Okay, so hobnob is second in that combination. It is second in that combination, and that is it. So it is 2 out of 6. Okay, so that is listing and what we call kind of single event probabilities. You just got kind of one thing to think about and pull one fraction together. All right, so these are a set of questions. Let's get them so you can see them all. There we go. So those are a set of questions, just 5 that will help you practice and cement those ideas today. And then obviously, as always, the answers will come up on the screen as well. I just flip between the 2, and then I will see you next session.